This video will give a short introduction to Chapter 5, which focuses on foundations for inference. Statistical inference refers to the process of using a sample to better understand what's true in a larger population. We talked back in Chapter 1 about the idea that the population is the entire group that we'd like to know about, and that often it's too difficult to collect data from an entire population. So instead, we collect data just from a subset of the population, the sample. We also talked about the fact that when we want to summarize a characteristic of the population, a numerical summary measure for the entire population is referred to as a parameter. And a numerical summary measure calculated from the sample is called a statistic. So in general, we're going to be using a statistic as a single number estimate, which we refer to as a point estimate, for the parameter. In Chapter 5, we're going to be focusing in particular on the situation where we're interested in one categorical variable, and the parameter that we're interested in is going to be P, the proportion in the population that have fallen into one of those categories of the categorical variable. So our parameter of interest is going to be the population proportion P. We will calculate from the sample proportion, which we give the notation P hat. And so we'll be using the sample proportion P hat as our best estimate for the population proportion P. Sampling variability refers to the fact that if I take different random samples from the same population, because I'm capturing different members of the population, I'm going to have different values for my point estimate. So just kind of thinking about this, if I've got an entire population, and in the population proportion is P. When I take a simple random sample of size n, I'm going to get a sample proportion. Say this is the sample proportion from my first sample. If I take a second sample, I get another sample proportion. They're likely not to be the same as each other, and they're also likely not to be exactly equal to the population proportion P. And every time I take a sample, I'm likely to get a slightly different estimate. In a real research setting, usually we only have data from one sample. And so in this case, we will use the sample statistic that we calculate to serve as our point estimate for the parameter that we really want to know about. If the sample is selected in an unbiased way, then the point estimate is a reasonable estimate for the parameter, but it's still not going to be exactly correct. And so understanding how our point estimates would be expected to vary from the parameter will allow us to figure out how large the margin of error is for our point estimate, and also determine whether a result would be likely to occur due to chance. And so these are going to sort of come into play in making confidence intervals with the margin of error, and hypothesis testing, where we determine if a result is likely to be due to random chance, or if it is not likely to be due to random chance and is what we call statistically significant. So those ideas are going to be introduced here in Chapter 5. Section 5.1 is going to focus a lot on describing the sampling distribution. The sampling distribution is just a distribution of statistics calculated from taking different samples of the same size, randomly selected from the same population. So remember before we were kind of thinking about how when we took different random samples, we'd get all these different sample proportions. If we looked at the distribution of those sample proportions, that distribution of sample proportions is called the sampling distribution for the proportion, and we'll learn about the characteristics of that distribution in Chapter 5, Section 1. Once we've learned about the sampling distribution, we'll start using it in Section 5.2. We'll talk about how to make a confidence interval for a proportion. So when a research question asks us to estimate a parameter, we'll generally use a confidence interval to do that. For example, if we're interested in what proportion of all US adults are vegetarian, here's some data from a 2018 Gallup poll. Found that 5% of US adults consider themselves to be vegetarian. And Gallup also tells us that results for this Gallup poll are based on telephone interviews conducted July 1st through 11th, 2018, with a random sample of 1,033 adults age 18 and older living in all 50 US states and the District of Columbia. For results based on the total sample of national adults, the margin of sampling error is plus or minus 4 percentage points. So thinking about this in terms of an interval, 5% plus or minus 4 percentage points would give us an interval that goes from 1% up to 9%. And I'm 95% confident that's somewhere between 1% and 9% of US adults are vegetarian. In Section 5.2, we'll be learning how to figure out how large the margin of error is, and also talking a lot about the appropriate way to interpret a confidence interval. In 5.3, we're going to focus on hypothesis testing. When a research question asks a yes or no type of question, we're generally going to address that question by conducting a hypothesis test. For example, does the use of body cameras change police behavior? Here is they look at whether they're changing behavior. They say that although both officers and the public generally support body-worn cameras, the impacts may have been overestimated. The study, which looked at 70 other body-worn camera studies published through 2018, found cameras have not had statistically significant effects on most measures of citizen behavior or citizen views of police. So when we're thinking about statistically significant, the way that we determine whether something is statistically significant or not is using a hypothesis test. When it says that it's not statistically significant, what that means is that it's plausible that any differences that were observed in the sample were due to random chance. So Section 5.3 will focus on the details of hypothesis testing, how we formulate hypotheses, how we measure the strength of the evidence provided by the sample data, and how we use our calculations to draw conclusions. So again, as we look at Chapter 5, 5.1 is going to focus on point estimates and sampling variability. 5.2 is going to teach us how to calculate and interpret confidence intervals for a proportion. And section 5.3 is going to teach us the basics of hypothesis testing in the context of doing a test for a proportion. As we go forward in chapters 6 and 7, we're going to be extending these ideas to other types of parameters, doing tests for means and difference in proportions and difference in means and all kinds of other things. But that's what's coming up in the next couple of weeks. So I hope this video helps you kick off the third week of class. Remember that if you have questions, I'm here to help. Have a good day.